So this is the first one I did for you, and I know the key's already on there, but we can go ahead and talk about it. I might as well. So we're going to start with that one. So you should be able to see, I spotlighted my phone. If anybody cannot see the problems that I have on the white piece of paper with the blue folder, that's what everybody should be able to see on the biggest screen. So hopefully it's working like it should. Okay. Okay, so I guess I'll go ahead and get started. It doesn't seem like anybody else is in the waiting room yet. So acids and bases, we technically have talked about these one time before. It's been a few units whenever we did chemical reactions, whenever we did the coloring sheet with the AB plus CD, and then they either rearranged or combined. Remember the synthesis reactions, the decomposition reactions, and I mentioned that we were eventually going to get to acids and bases. Well, that's where we are now. So we have briefly touched on it, but really nothing in detail. And it's actually a pretty complicated topic, but there's just the basics that we need to understand are who's the acid and who's the base. And if you can identify that, then that's really the point of this unit, okay? And there's a couple of tricks that can make it a lot easier. I know whenever you look at a chemical reaction like this, it might seem a little overwhelming. You're not sure really what you're looking at. And so the first thing that I think is important to do is to get a pen or pencil and draw pairs. So on the left side of the arrow, remember that's whatever we are starting with in the reaction. Those are the two things that are reacting together, okay? On the right side of the arrow, that is whatever the end result is, okay? So, sorry, I'm still adding people to the meeting. On the right side of the arrow is the end result. So these two over here combined in some way to produce these two products over here, okay? On the left side of the arrow, you need to determine who's the acid and who is the base. Basically what that means,
it's Katie's class.
What we care about the most are the hydrogen protons. So that's really, you can pretty much ignore everything else that's going on in either substance. In an acid-base reaction, somebody is donating hydrogen protons and somebody is accepting, right? And so what I put on the PowerPoint that might help you remember that is this. I hope I'm writing that big enough. Okay, so bases accept and acids donate. Okay, I'm going to go ahead and write that here. Bases accept, acids donate. And I still kind of have to say that to myself every now and then to remember. I know it's a pretty new topic. Okay, so like I said, another thing that you can look at, I know we've talked about charges before. In this reaction, somebody's going to gain a proton and somebody's going to lose a proton. And if you remember that protons are positively charged, if you look at the charges after the equation, that might also help you kind of double check your work. So for this example, like I said, it's good to draw pairs, okay? So H3PO4 right here and H2PO4, that's the same substance, okay? So I'm going to go ahead and connect them here. Right? I can tell they're the same because they're barely any different, okay? Same thing here with water, H2O and then H3O plus, that's clearly the same substance, okay? Neither of them contain phosphorus, so that lets me know that those are the two pairs, okay? So whenever I'm starting over here, H3PO4, okay, at the end of the reaction, it's now H2PO4, okay? So they have lost a hydrogen proton. I know that because it went from H3 to H2. Like I said, PO4 doesn't change, okay? The only thing that's involved in this reaction is the hydrogen protons. So if I went from H3 to H2, that means that I lost one, okay? So now if I look down here, it looks like if I lost one, that means that this must be the acid, okay? Admit somebody, okay? So this is the acid right here, and I know that because it clearly gave one away. It went from H3 to H2. Nothing changes with the PO4. In an acid-base reaction, we really only care about the hydrogen protons, okay? Make sure there's nobody else. All right, and so if that's the acid, this must be the base, but we need to go ahead and try and talk ourselves through it just to confirm. So H2O went from H2O to H3O. So clearly it gained a hydrogen proton. Okay, we went from H2 to H3. And so this must be the base because it accepted the hydrogen proton. Okay, so that's how you identify acids and bases, and that's why I think it's important to draw the pairs, because if you don't, it's a little confusing, because if you're looking at H3PO4, you're not really sure. You can tell there's been an exchange of hydrogen protons, but it's important that you can see the change from here to here, and then the change from here to here. And if you're ever working through these and you write acid twice or base twice, that's impossible. You have to have one acid and you have to have one base, okay? So that was the first part of the assignment. It also wanted you to identify a conjugate acid and a conjugate base, okay? And I'm going to keep this as simple as possible. Notice that I have this arrow drawn not only in one direction, okay? A lot of chemical reactions, not all of them necessarily, but a lot of them can move in the opposite direction, okay? So what that means is every acid has a conjugate base and every base has a conjugate acid, okay? So what you can do is say, okay, we already determined that this was the acid, all right? So this must be the conjugate base, and I'm gonna go ahead and write that and then tell you why that's true, okay? And you can just abbreviate that by putting CB, okay? So now let's imagine that this reaction moves in the opposite direction. And for right now, I want you to ignore what's going on with water and hydronium over here. Don't worry about it, okay? So if this reaction moved in the opposite direction, and I went from H2PO4 back to H3PO4, now I have gained a hydrogen proton, okay? And remember, if you gain a proton, if you accept one, that makes you a base, okay? But that is if it moved in the opposite direction, okay? If you want to, and this is usually what I do, especially if I'm in a hurry, once you identify the acids and bases, and if you have the arrows drawn, whatever's the acid, whatever's connected to it, that's the conjugate base. Whatever is the base, wherever the arrow is connected to, that's the conjugate acid. And I'll talk you through that one too, okay? So H3O, if this reaction moved in the opposite direction, it would go from H3O to H2O. So now it lost one, and that makes it a donor, okay? And like I said, this topic I know is complicated, but this is really as we're going to get into it, okay? And I know this one was already, I wanted to go ahead and talk you through it. I'll be honest, I'm not as concerned with you being able to identify the conjugate base and conjugate acid. I'm more concerned with you being able to look and say, okay, which one's the acid and which one's the base, right? That's really what I think is more important. But this acronym should help, and like I said, I still kind of have to say that to myself every now and then. And I'm going to take pictures of all this and put it on the classroom. So I'm going to go ahead and move on to the next one. So the next one was this reaction. I didn't number them because I don't remember if I numbered them on the paper, but this was the second one. First thing that I'm going to do is draw arrows, okay, to figure out the before and after. And this one's a little bit easier, okay? One pair contains nitrogen and one pair contains sulfur. So here's the before and after for this one. And then here's the before and after for this one. And like I said, it's a lot easier because this one pair contains nitrogen and one contains sulfur, all right? So now that I have that, I'm going to focus on the left side of the equation, okay? And it doesn't really matter which one of these you start with first. You don't have to identify the acid first or the base first. It really doesn't matter. Okay, but I'm going to start with ammonia over here. That's NH3. Okay, and remember, we only care about what's going on with the hydrogen protons. Somebody's gaining one, somebody's losing one, all right? So I went from NH3. I know that's kind of hard to, that's a 3 right there. I went from NH3 to NH4, okay? So I gained one. And if you remember our acronym, bases accept, acids donate, okay? So clearly they accepted one, okay? They got a new one from somewhere. That means NH3 is the base, okay? So that must make this one the acid, but we still need to go ahead and talk ourselves through it, okay? All right, we went from H2S to HS. And remember, if there's not a subscript here, which there's not anymore, that means that there's just one hydrogen atom, okay? So clearly, H2S lost one, okay? Remember, acid donate. So this is the acid. Like I said, you only care about what's going on with the hydrogens. We don't care. Nothing's going to change with nitrogen. Nothing's changing with sulfur. The only thing that's changing is the hydrogen protons. And I do want to point out there are 3, 4, 5 hydrogen protons on this side, and there's 4, 5 on this side. Remember, the total number is not changing. They're just, somebody's giving one away, and then another one is accepting them. Okay, but that's really all we care about are the hydrogen protons. So every base has a conjugate acid, and then every acid has a conjugate base. And you can just abbreviate that with CB or CA. Does anybody have any questions about this one so far? Like I said, I'm more concerned with the fact that you can do this over here. Who's gaining one, who's losing one? You just kind of have to say, okay, if I went from 3 to 4, I clearly gained one. Okay, and if I went from 2 to 1, I clearly lost one. Okay, so just kind of pick out the most important parts. But does anybody have any questions about this one before I move on to the next one? Like I said, I'm going to post pictures of this, so you can look back at it later. Okay, I'll go ahead and move on to the next one then. The next one was this. Okay. And I always start by drawing the lines. I think that helps. Okay. So this one's also fine because this one contains carbon and nitrogen, and so does this. So clearly, these are a pair, a before and after. And then here's H2O, H3O. That's also a before and after. Okay, so left side of the arrow, we need to figure out who's the acid, who's the base. Okay, so I'm going to start here. I usually just start with the left, but you could start with water if you want to. And if you remember from the PowerPoint, water is one of those substances that can be an acid or a base. So it's not necessarily like you can remember, oh, water's always the base or water's always the acid. Water is amphoteric. If you remember from the PowerPoint, they can be either. So you still have to work through it each time. So I'm going from HCN to just CN, okay? So that hydrogen proton is gone. And if you remember our acronym, bases accept, acids don't. So clearly, hydrogen cyanide over here, okay, was the donor, was the acid. It went from HCN to just CN, okay? And hydrogen protons are positive. So that's why when they gave up that hydrogen with the positive charge, that's why they're now negative. Okay, so that's one way you can kind of check yourself. Okay, water went from H2O to H3O. So they gained one hydrogen proton. Remember, bases accept. So this is the base. I don't care at all what's going on with carbon, nitrogen, or oxygen. In an acid-base reaction, all we care about is what's going on with the hydrogens, okay? The total number is still going to be the same, 2, 3, and then we still have 3 over here. The total number is not changing, okay? They're just kind of exchanging them, okay? Questions about that? Like I said, I think it really will help you to pair them up because like I said, it can be kind of overwhelming to look at. But every acid has a conjugate base, and then every base has a conjugate acid. I'm not that concerned with the conjugates. Technically, it's in the TEKS though, so I did want to show it, but this is, I think, more important. Questions before we move on? I think we only have one more. Okay, last one. Okay, so I'm going to draw my pairs. All right, so HNO2 looks like nitrogen's involved. That means this must be its before and after. Okay, and then again, we have H2O and H3O. The reason that water's involved in almost all of these is water's just a really common player in an acid-base reaction. Water's usually always involved, and that's because it can act as an acid or a base, so it's really versatile. All right, so let's take a look at this. I'm going to still start over here on the left. All right, I went from HNO2 to just NO2, so that hydrogen proton is gone, okay? Remember, bases accept, acids donate. So clearly HNO2 gave up its hydrogen proton, okay? So that means it is the acid. All right, remember, I don't care what's going on with the NO2. Nothing changed about that, all right? All right, water went from H2O to H3O. Okay, so water gained a hydrogen proton, all right? So this was the base. And I think in all of these examples, actually, water was a base. That's not always the case. Okay, I should have put one on there where it was an acid, but it's just as long as you know it can be either. Okay, so every acid has a conjugate base, and every base has a conjugate acid. Okay, and like I said, this acronym, I still write it out every time. You might as well. Okay, and like I said, you can use these charges to check yourself. The base, remember, bases accept hydrogen protons, and if you remember, protons are positive. That's why whenever they got a new hydrogen proton, they're now positive. Okay, the acid over here, remember, acids get rid of positive charges. Okay, so that's why the acid ends up as negative. You can use that to check yourself. You don't have to. I just thought I might as well point it out. So questions about that? Questions about any of them? I'm going to post them on Google Classroom. But like I said, acids and bases, it really is a lot more complicated. But we're just going to have to hit the high points.
That's why I was so confused when I first looked at it.
Oh, about what part?
All of it.
Yeah,
like,
and I know.
When I first looked at it, I was like,
This is definitely one of those units that I wish we were in person for. But like I said, I'm really more concerned with, like, on each of these, can you deal with the left side of the equation? That's all. I just want you to know who's the acid, who's the base. And if you can do that, that's good enough for me. Okay. So I think next week we move on. I mean, it still involves acids and bases, but it's not like this. So like I said, I just attempt the assignment, do the very best you can. There's a lot more to acids and bases, but we're just not going to be able to get there. There's a lot of math, and I don't know who has a scientific calculator at home and who doesn't, so we're just not even going to deal with it. So I'll leave this up for just a second. Oh, Dacia's here. Just in case. But like I said, even for me, and I've done this now like 3 times, it really does help me to draw those arrows. And like I said, if you're ever writing acid twice or base twice on the left side of the arrow, you've done something wrong. You have to have an acid and you have to have a base. You can't have 2 acids and 2 bases. Okay. For the right side with the conjugates, every acid has a conjugate base, every base has a conjugate acid. And I'm honestly not as concerned that you can do that part. But does anybody